Hey, everybody. Good morning. Thank you for attending our Tech Talk today. We're really excited to have you all here, especially since we have GTC happening. So there's a lot of competition for your attention. So we really appreciate you having you here today with us. So I'm excited to bring today one of our AI ecosystem partners, Picovoice, who will be showing their amazing no-code voice AI platform, Shepherd. This is super exciting. So I think you're going to really enjoy this. So let me introduce who we've got. Today we've got Ali Kanasari Anari, who is the CEO of Picovoice. And in his previous life, he was an engineer where he spent his time tinkering about AI, machine learning, and high performance computing. And we have Reza Rostam, and Reza is the embedded lead at Picovoice, where he spends his time making voice AI efficient and accessible to the masses. How are you doing, Reza and Ali, today?
Great, thanks for having us here. Excited about this.
Yes,
Great,
yes.
thank you for the introduction.
Yeah, of course. And feel free to add anything else you would like. So let's get going with some housekeeping, and then I'm going to let you guys take over. So if you want to go to the next slide. So again, you can see this on demand at the YouTube channel. If you have to, you missed some of it or want to see it again, we have a lot of our other virtual tech talks are there. Tweet at Arm Software Dev if you enjoyed this. I'd love to see what you thought about it, and let everybody else know in the Twitterverse. And also, don't forget to fill out the survey. We want to keep bringing you these talks from our partners and Arm engineers, and we really enjoy doing it. We want to make sure that we're bringing you the information you want, the topics. So we're super open to suggestions. So if you fill the survey out, you will be put in a drawing to win an Arduino Nano 33 BLE board. And we love giving these away. We have a ton of them. So feel free to please tell us what you think, and we'll get you in the drawing. Next slide, please. And these are coming up chats, our tech talks that we want to bring your attention to. So we've got SenseML that's going to be coming in a couple weeks. And then a company who will be talking to you about PyTorch models. This is something that not a lot of people are doing yet, but this is going to be a good one. And then Imagimob on May 25th. They make super ultra efficient TinyML applications. So these are gonna all be great. Please register and come and hang out with us again. All right, so I'm gonna let Ali and Reza take over. I have to just say one more thing that's super exciting. So the Picovoice guys are giving away 10 free enterprise accounts for free, which is like $9,600 value. So Ali will say a secret word at some point during this presentation, and the first 10 people who email at hello@picovoice.ai will be put in a drawing, and the first 10 people who email will actually get that. So we'll put that in the chat window so that you guys have that email address handy. And please feel free to ask questions at any time. We will get to them, and I will stop talking now. Ali, Reza, take it away.
Hey, thank you, Mary.
All right.
All right. So what we kind of want to show you guys today is first a bit of a housekeeping. So we make introductions, what we are doing, how we are helping, and why what we are doing is hard. And then after that, after I do all the boring CEO talk, Reza is going to actually show you guys the real deal. So he's going to actually build a voice assistant in front of you using our platform and ecosystem, and then we deploy it into an Arm microcontroller. So before the end of the talk, we should be able to build something together, and hopefully that would be something that you guys can take as a starting point and start building your own voice interfaces and voice assistants on Arm Silicon IP. So let me just give you guys an introduction who is in this call. So I'm Ali. I'm the CEO of Picovoice. I also think of myself as an engineer, as Mary mentioned. And then we have Reza, which is overseeing all our embedded efforts in Picovoice. So I guess, like, let's just start with who are we and what are we doing? So at Picovoice, what we are really trying to do is give you guys a platform that lets you build experiences, voice experiences, very similar to Alexa, but different from Alexa or Google. We want to run 100% on the device. And then by virtue of running on the device, we are private, we are reliable, and we are zero latency. So that's pretty much is the mission statement for the company. We want to enable you to build experiences like Alexa, but then we want it to be 100% on device. And then we want to give you all these nice features that you need to actually have something performance. Now, you might want to ask, like, why we need a company to do this? Isn't it something that is a solved problem? And now what I want to actually show you guys is why doing voice AI on microcontrollers is hard. And the reason I know it's hard is because about 10 years ago, I actually had to go through this experience that I'm going to actually show you here. And I had to build a voice interface back in 2010. And the experience for me as a developer was horrible. And that was one of the motivations to start Picovoice. So imagine that you're in a company and you need to actually build a voice interface for a product, whether it's a going to be device or app or something, and you need to deploy it to a microcontroller. So what's the first thing that you need to do? You need to design it, right? It's like, voice is like an interface, like not that different from graphical user interface. You basically need to design what this interface does, right? So here's the first gotcha. So when you're actually designing it at the beginning, without having customer feedback, you basically just need to make a wild guess what the customer wants. And like people who've been into startups or people who have built products, they know that this is not a good idea, because what you really want to do is like have that close contact with customers or focus groups at the beginning and do less guessing. So that's the first reason it's hard. Now, imagine that you actually create that first guess, you get buy-in from product team, you get buy-in from the executive team, and now you are actually going to build it. So first thing you need to do is actually go collect some data. So if your voice interface has a wake word, or if your voice interface has multiple voice commands, you've got to go and actually record thousands of people saying those things. And then you get to actually train something. So what are the gotchas with this step? The first one is like data collection is actually really hard or expensive, or possibly both. Because if you think about it, you need control data. So you need to actually record a balanced set of speakers, whether that balance is going to be about their gender, their age, their demographic, and you need a lot of them to have a performance, voice interface. So you either do it yourself, which basically means that you need to build an infrastructure to do it, or you actually subcontract it to someone else, which becomes extremely expensive. And guess what? If in the middle of all this, the product owner or one of the stakeholders, they change their mind. They're like, you know what? We're not going to call this product X. We're going to call it Y. You got to restart again. So all that data that you gathered already, you can throw it away and start gathering and training models again. So it becomes quite tedious and it becomes quite brutal because you can't really iterate the way the product team or the marketing team wants you to. Now, assume that you go through all this, you have your data, you design the voice experience. Now you got to actually go choose a hardware. Even if you have decided that you're going to be on Arm Cortex-M4 or Arm Cortex-M7, guess what? There are just so many companies making Arm Cortex-M4 chips, right? And they all come with different variations and different bells and whistles. Some has more RAM, some has less RAM, some has a lot of flash, some don't have any on-chip flash. And so you kind of need to make a wild guess. What hardware should I pick for the model that I trained? So I can actually run this in real time, because keep in mind, like unlike some other AI applications that you can have or you can afford to have some latency, you can't actually have that for voice. It needs to run in real time, otherwise it just wouldn't work. Now, after you've done all that, now you get to build a prototype. And here comes the moment of truth. When you build that prototype and you wrote all that firmware and put the model on it and optimize it, does the customer actually want it, right? Because remember at the step number one, you made a wild guess what the customer wants, right? And if that's not the case, I mean, there are two ways that you can come out of this. Either your organization is like, stubborn enough that, hey, we're going to do this again, or they're just going to say, well, we tried and we failed. Let's just not do this. So that was my experience building Voice AI 10 years ago. And that's more or less the experience today unless you're using Picovoice. Now, we can't help with everything that is involved in building a voice AI product on hardware, but we can help a lot with a lot of different steps, especially if you're a developer or stakeholder. So let me show you how the Picovoice way works right now. So we have a platform, we call it Picovoice Console. Reza is going to actually use it today. And what this platform lets you is that it lets you design those voice interfaces that we mentioned, train models for them, and test them right away without needing to collect data and without needing to train anything yourself manually. So you can literally go to the platform. It's a web-based platform, sign in, type in what you want, very similar to the way you will Alexa's skills, and then you actually can try it out within minutes. So what this does for you is that it really reduces your time to market. So instead of spending months or weeks for trying to actually gather the data and make sure the data is good, you basically can actually rely on us to do the same thing for you and shorten your time to market, which is critical. And again, it becomes reducing the risk because time is the most valuable thing in the product team. And then the other thing it lets you do is lets you focus on the user experience. So initially, instead of actually you trying to guess what the user wants, you can actually ask your users to try this out. So you can actually focus on the user experience and see if what you're building, regardless of all the technicality, has a good user experience, which eventually is what you need to be able to sell the product to the end customer. Now, you've trained models using Picovoice Console. Now, here comes the part that you actually need to deploy it into hardware that represents the end product. So previously, you had to guess what the hardware is, and you had to actually do some work to put your model on it. So what we did in Picovoice is that we created the platform we call it Picovoice Shepherd. And what it allows you to do is to grab those models trained with Picovoice Console and deploy it into a set of widely adopted microcontrollers running Arm Cortex-M within minutes, without writing any code. So you can literally grab those things that you have in a web browser, and they were nice and good, but they're still not on target hardware. You can actually grab them and put it on a microcontroller, even if you're not a software engineer. And that can happen without writing any line of code, even a single line of code. So really the main benefit that you get here is that you can actually stay hardware agnostic, right? So you can actually say, hey, I made a commitment, I want to use Arm Cortex-M. But you are not ready, or you're not ready at the point that you say, well, I'm going to use this semiconductor company. You're like, well, I want to keep my options open. I don't know where this is going. I might actually go with this semiconductor company or that semiconductor company, and there's so many different variables there, right? So Picovoice Shepherd first allows you to actually do things really fast, but second, the value that it adds you is that as a customer, you can actually remain hardware agnostic because we support a wide variety of hardware. Now, once you're there, you actually have your voice interface running on a microcontroller, right? So you can really grab that piece of hardware and show it to your customer and make them use it. And you can 100% simulate or emulate how the voice interface would work with focus groups or external customers, right? And then this allows you to iterate really fast. So keep in mind, in the previous slide, going from beginning to this point is like a few months of work. And it's a lot of money that you need to spend. In this slide, going from beginning to the point that you have something running on hardware that you can show to customer, this can all happen within a couple of hours. And my hope is that if we all do it right, by the time you're done with number 3, you have created alignments internally within your organization to actually get the buy-in to build the product, and externally to know what the customer wants or have a better, educated guess. And now you're done with all that. You now need to build your product. But what we did for you is we reduced the time to market. We actually reduced the risk quite a bit because now you actually have actual feedback. And now you can actually put engineering resources and go build your product. At the end of the day, you need to write code. At the end of the day, you need to build a product. But what we did, instead of floating it up front, is delayed it to the latest stage. So you actually are taking on less risk at the beginning. And when it comes to building your product, the value add that we are giving to you as Picovoice is that we actually have a lot of open source reference designs and demos that you can actually use as a starting point to accelerate your development. All right. Now, one thing I want to mention about Picovoice is that we are very much a developer-focused company. So day and night, what we're thinking is that how can we actually make the experience of the developers building all of these products better? Because we are all being developers at some point in our career. So different from other options that you have in the market, like you really need to go talk to the salespeople and go talk to the marketing people to actually get to try it. We don't believe in that. What we believe is like we want to give you what we need to get to build the confidence that this is what the technology that works for you. So after today's talk, if you guys are interested to try it out, you don't even need to talk to me or anyone in my team. You can actually go to this URL. You get all the documentation, all the starting points to start building what we're going to present to you today yourself. And you can do it for free. You don't need to even commit to anything. So that pretty much wraps my part. So if you're ready, maybe it's actually time to build something for our audience.
Let's do it.
Thank you, Ali.
Yeah.
Yeah, sure. Let me just share my screen. Okay. So can you see my screen now?
Yeah.
Oh, great. So let me just move this one here. Okay. So at this point, I'm going to show you how to use Picovoice ecosystem around Arm Cortex-M microcontroller to create your voice experience, voice interface. So let's start with Shepherd. Shepherd enables you to test and deploy a voice interface into a microcontroller within a minute. So for that, you need to just have Python on your system. And then simply install Shepherd by typing pip3 install pv shepherd. Okay. And that's it. Now you can start Shepherd by typing pv shepherd. Let me grab the main page. So Shepherd has three main parts. At the beginning, you need to select your board. For this stack, I choose a STM32F469, which has a very nice LCD and has an Arm Cortex-M4 chipset. So let's select that one and upload the firmware. So this step, actually uploading the Picovoice firmware to the board, and it takes a couple of minutes, I would say. But before uploading the firmware, just make sure that your connection from board to the computer is stable. That's it. Okay, so at this point, if everything is done correctly, you should be able to see this beautiful Picovoice screen on your LCD. So here you will see the unique ID for the chipset. We're going to use this number to create custom wakeboard and context model in Picovoice console. For now, we just ignore this part. So as for models, when you say something like Alexa, turn on the light, Alexa is basically a wake word, and turn on the light is a follow-on command. So Picovoice AI has two internal engines, Porcupine and Rhino. Porcupine continuously is listening for the wake word, and when it spots that wake word, wake up the Rhino engine, and Rhino extract all the information from the follow-on command. So as you can see, the default model for Porcupine is Picovoice, and the context is a smart lightning. So let's go for now with the default models and deploy default models. This is a control center. So Shepherd gathers all the information in real-time fashion from the board, and you can see the mic level, CPU usage, and the board is actually listening for the wake word here. There are some tuning parameter here, and you can, based on your application and environment, you can change the Porcupine and Rhino sensitivity and improve the performance of the engines a little better. So let's test the default voice interface. Picovoice turn off the light. Okay, I forgot to show you the context. So by clicking on the context button here, you can see all the expression that can be understood by the Rhino engine. So these are all the expression that you can use. For example, you can change the color of the location, and you can see a list of the color here and also location. So let's try another expression here. Picovoice, change the color of the kitchen to green. Okay, nice. So if I enlarge this window, you can see Picovoice first detect, oh, sorry, again. So Picovoice Porcupine detects the wake word first, and Rhino extract the following command. So after that, we want to create our custom voice interface, right? So for that, we need to go to Picovoice console. Okay, go to console. Okay. I need to log. Sorry about that.
This is the magic of demos. You get to see,
Yeah.
100%.
see all the speed bumps that sometimes happen.
Okay. Yeah. Okay. Now we are there. So as I mentioned before, we have two engines, Porcupine and Rhino. Let's start with Porcupine. So for a custom wake word, you just need to come up with a good phrase. So for this talk, I'm gonna go with "Hey Arm," right? And then oh, okay. So let me go with my
The hardest part of doing this is to figure out which account to use.
yeah. Okay, it seems I use all my available wake word. I can use my other account here. Sorry for this technical issue, as always.
No problem. If there's any questions from anybody out there, please feel free to put them in the chat. We can get through a few questions while Reza works through the
I guess I'm good here.
technical.
So,
Okay, awesome.
hey, so again, hey, Arm. Then if you're happy with the wake word, you just need to click on the train wake word. At this point, Picovoice console asks you about the platform. So we are supporting a lot of platform, and you need to select Arm Cortex-M. And now console asks you about the unique identifier. So we have seen that one before. So you need to switch back to Shepherd, go back one step, and simply just copy this unique identifier and paste it here. So this model is just for this chipset. And then train your model. Training the model, the wake word model, takes a couple of hours because Picovoice console creating the most optimized model for the wake word that you've selected. But meanwhile, you can go here and select your keyword, click on the mic button, and give the permission for sure. Hey Arm, hey Arm. So you can test the wake word within your browser. That's a good feature. That's a very cool feature. So while the wake word is being trained, we can create our custom context by going to Rhino part. For this part, let me go to Chrome again. So for context, we need to create a name. I'm going to go with generous coffee maker. And as the name implies, I'm going to select coffee maker as a template. Create context. So it's a context, and by clicking on the context name, the context builder is going to show up. And since we have selected the template, there are some default values here. For intent, there is a order beverage intent, and there are all the way that you can order a beverage as the expression. And here, if you see, there are some variables, and these variables, which are called slots, has some values. So beverage is a list of all the beverage that you can order, for example, and different size. So let's create another intent. I don't like to order a beverage, so I like to donate the beverage. And so now I need to add expression to capture all the different ways that you can donate a beverage. So let me give you a coffee, for example. So in this way, I need to create different expression for different beverage, right? But that's not a very smart move. So I can just create, using the beverage slot, I can create donation. Oh, sorry. A variable and save the context. I can also go here and add another beverage, try, save it again. And once I'm happy with the model, I can first test it similar to Porcupine within my browser. Let me give you a chai. Okay, so it captures what I wanted. And then just train it. The same thing, Arm Cortex-M, and paste the unique identifier. Agree to the term of use, and train the model. So training the Rhino model is pretty fast. So I guess, yeah, it's done. So basically you can, and you can see here, this model is just for this chipset. So you can download the model and then extract. Okay, so it's a moment of truth. Let's go to Shepherd again. And so I downloaded the Hey Arm wake word before. So now I can just go to my download folder, select Hey Arm as the wake word, and select generous coffee maker. Is it this one? I guess so. Okay, let's go and upload the new models. Okay, this screen is the same as before. The only thing is different is here. The board is listening for the new wake word. And also, if I go to context again, you can see there is a new intent and new expression. And chai is added to the list of beverage. So let's try the board again. Hey Arm, let me give you a chai. Nice, right? Okay, so far we have created, tested, and deployed our custom voice interface into the device. Now we want to know how to integrate the whole voice interface into our embedded project. For that, Picovoice has Picovoice MCU SDKs. So let's go to Picovoice GitHub page, and we have a Picovoice repository. So let's go to that one. And here we have different SDKs. For example, if I go to demo, you can see we have SDKs for different platforms. And if I go to MCU, there are several demo projects. Since we are working with STM32F469, I'm going to use this demo project. So for that, let's go to Picovoice, get this repo. After that, I need to, let me go to this page again. I want to show you something. Okay, so for compiling the demo project, you need a toolchain and an IDE. For this board, I'm going to use STM32Cube IDE, which is the official ST IDE. It's also free. To work with audio, you need to download one extra library. And also to see the output of the board inside your computer, you're going to need a serial monitor. I'm going to use CoolTerm. And all these, all the tools that I've used here in this talk are free and cross-platform. So they are available on Windows, Linux, and Mac OS. So let me fire up STMID and already import the project here. So in this project, there are two important files, main.ca. This file defines all the variables and functions needed by Picovoice engine. So basically, I define the Picovoice, I init the Picovoice, and pass the audio buffer to the Picovoice process. That's it. That's the only things that you need to do in your project, and the whole main file is less than 200 lines. There are two important functions here: wake word callback and inference callback. So Porcupine calls wake word callback when it spots the wake word, and Rhino when it reaches to a conclusion called inference callback. And you can do whatever you want inside this function. I just simply print a wake word and play with the LEDs, but based on, for example, the inference intent, the slots, and the value for the slot, you can do different things. And another important file here is PV params. If you go to Picovoice init, you can see we're passing two arrays to Picovoice init. These are basically the Porcupine and Rhino models that we downloaded from Picovoice console. So let me open this one. So keyword array is just an array of numbers, and context is the same. So these are now have default values for Picovoice and Smart Lighting context. But you if you want to import your models, you need to change the models which are in binary format to a text format. For that, there's also a Python script on Picovoice repository. So when you download the Picovoice repository, you can go to the folder resource script, and there is binary to array Python. And if I run this script, you can see you need to provide two files, a binary input file, which would be Porcupine and Rhino models in binary format, and another output array file, which are basically text. So for the sake of time, I did all those steps before. So I can just go to desktop, open context and wake word models. So as you can see, these are just numbers. Let me copy and paste these values. So because that's wake word, I need to replace the context of the wake word array, and the same thing for context. Okay, so that's it. Now I can compile the project. Okay, the binary is generated. Upload the binary output to the board. Hopefully there's no problem. Okay, great. Okay, so the board now is listening and the output is sent through UART to the computer. So we need a serial monitor. As I mentioned before, I'm going to use full term. Let's wait for verification. Okay. So in cool term, I just need to go to option and make sure that the baud rate is 150,200. Click OK. Click connect. Okay, let me. Yes. Okay.
So Ali, if somebody were to try the, running through what Reza's doing, is there good documentation so that they can go and get started and be able to successfully create their own project? And that's all on your GitHub?
That's on our GitHub and also on our website. So
Right.
in this slide, the last slide, I'm going to actually send it to attendees right now, along with the secret board. But you basically, all you need is just go to the document section of our website, which is that getting us started blue button on the top right. And then read over.
Cool.
Yeah, everything is pretty much self-service. So you can actually sign up for everything yourself, like a single sign-on, and then just download everything the same way.
Great. Yeah, I was watching Reza do this. I'm like, how's somebody going to remember how, all the little things?
Yeah.
I also kept trying to jump in with questions, and it was so fast. Like, I thought it would take a minute to process. I'm like, oh, let's squeeze in a question. It's like, oh, it's done. It's very fast. So just wanted to point that out in case anybody else did not notice how quickly Shepherd processes.
Yeah, true. The whole process is like 20 minutes, like less than 20 minutes. Yeah. Okay, so we're almost done here, so no worries. So first,
no rush. Just I'm enjoying this. So keep going.
Yeah. So if I remember, okay, so we're done with uploading the project. So now the board is listening for the custom wake board and the follow-on command. So I can literally test that one here. Hey Arm, let me give you a try. Okay. So basically, you create a project and you integrate the custom voice interface that you build in Picovoice console into this project. And that's it. That's everything that you need to do for having a voice interface.
Yeah, 10 years ago, that was 6 months of my life. So it's kind of impressive to me. It's like, oh, cool. Like, I could have saved 6 months, like do it in 30 minutes.
6 months has been reduced to 20 to 30 minutes. So talk about time to market.
It's like Matrix, right? You can actually just plug in something to your head and, Kung Fu in like 5 minutes. More or less.
Yeah, it is.
Yeah.
You're like, I know how to build a wake word. So let's see. So there's been a couple questions that have come in. Feel free, please, everybody, if you have any other questions, that's what they're here for, to answer, anything you want to know about this. A couple that popped out to me is the total device flash and RAM footprint needed for one Porcupine wake up word in a simple Rhino context is 2 options plus default. Sorry, I don't understand feedback. So those basic commands. And you said the minimum right now is 300 KB of flash and 70 K for the very smallest model, right? Is that correct?
Yes, that's pretty much correct. So if you think about it, like, the smallest kind of CPU we are targeting right now are the really low end Cortex-M4s that you can buy in the market for like well below $1. And they have about 0.5 MB of flash and like less than 100 kilobytes of RAM, and we can run comfortably on them. Now, one thing that is important to know about what we presented to you is that it's very scalable in the sense that you can have multiple wake words, you can actually have many intents, many voice commands, and we're going to still use similar amount of flash or RAM and probably with similar amount of CPU cycles. So we kind of had to build a technology in a way that it can scale as you're scaling your voice interface to be more complex.
Yeah. Yep. Cool. We've got questions flying in, which is awesome. So thank you, everybody. Let's get to these. So this is a good one. Which languages are you supporting right now for wake word and NLU? And which languages are in your roadmap?
So right now, right at this moment, we support English, French, German, and Spanish. In terms of immediate roadmap, we have Korean, Japanese, Italian, and Portuguese. Now, with language support, we are treating it as something that we work backwards from the customer. So if there's a customer who needs, like, a given language, and if we engage with them, we just, prioritize that. But that's the state of things right now as we speak.
Yep. Nice. Will this run on other dual ARM ST micros? So like the STM, the 32157A. Randall, question comes from Randall. He hasn't been able to browse your website. So
yeah, no. So for STM32, what we're supporting right now is STM32F4, STM32F7, and STM32H7. So the H7 is a dual core ARM Cortex-M4, ARM Cortex-M7. It's possible to support other ST microcontrollers as well, but I mean, it's just not the case right now.
Yeah, cool. Let's see, for Shepherd provisioning, is there or will there be a CLI for pushing firmware on initial setup?
Oh, so I guess I want to make sure I understand the question properly. So Shepherd is a graphical tool. So you basically push things to the target using the graphical tool. If you're at the point that you're like, hey, I'm like the super user and I want to actually do things through CLI, my suggestion is like, don't use Shepherd, go use the tools that comes from the semiconductor company.
Yeah, okay. Let's see, any plans on mining the data collected to analyze behavioral patterns of users?
So we don't collect data from our users. I just want to be 100% clear.
Yeah, I was going to say that's probably the right answer.
So we don't collect, good trick, but
yeah,
I was raised there. But like we don't collect user data. Just a note on that. I mean, like, there's all this talk about like, well, voice companies collecting user data, and this is not, ethical, and it's not fair to the user. We don't do that, and I don't think that's the right way of trying to tackle the problem. There's just so much open data out there that people actually put it there themselves with permitted licenses that you can use them. You don't need to actually go and gather users' data against their will.
Right. Exactly. There are other ways to do it, or like ask people to opt in and tell them, like, this is the thing, right?
Yeah, exactly.
Back to the language thing. Quick question: is there a plan to support Chinese language?
Not at this moment, but if there is a prospect, then we can actually engage and discuss that. But it's very much doable.
Cool. And then another language is simultaneous languages, so like English and Spanish simultaneously.
Yeah, I like that. So we have a demo on our website that actually supports 4 languages simultaneously.
Cool.
So if you go to the main page of our website, I think even if you just scroll down a bit, so see that if you go to the main page of our website, the smart lamp demo that you see, it actually supports English, German, French, and Spanish at the same time, right?
English.
Awesome.
Yeah.
English.
So you can actually try it in like different languages. So that we have that capability.
Cool. That's awesome. Everybody should go try that out. I might try that out.
That's actually super fun. It actually shows you how much German and French you know.
Yeah. No,
Mine
it's great.
Great.
Mine's not either, but it'd still be fun to try that. Benchmarks. There's a question about, have you had any benchmarks comparing with like Sensory, for example?
Yeah, so we have open source benchmarks on GitHub. for every product that we have out there. So you can actually go check them out. It's open source and open data. So you can reproduce them, or you can actually plug in the data you want, or you can actually tweak them that you want. For that specific question about comparison to Sensory, we don't, just because Sensory's end user agreement doesn't allow benchmarking, if that makes sense. So we might have internal benchmarks, but we can't publish it.
Yeah. People could feel free to go do their own too, and just try projects
100%.
out and see how they work, and it'd be interesting. So,
yeah, our stuff is open source anyway, so you can go grab it, and then if you're using Sensory, you can grab their stuff and then do the bake off yourself.
Yeah, cool. One question that we haven't gotten to yet is the cost of the service.
Good question.
What's the business model look like?
So if you guys are actually using it for a personal project, or like you're a researcher or student, you can use it forever for free. Don't need to pay us at all. Now, that being said, you won't be able to build a commercial product with it. It's going to be for you as a hacker or as a personal user. If you're an enterprise, you do get a 30-day free trial that you can actually use whatever we showed you here for free. And then at that point, if you want to engage with us, we have a pricing page on our website. If you can actually just go back to our website and then go to pricing. I think this picture shows really well how we engage, right? So if you're a personal user, you get access to our SDK, you get access to console, use it for free, but you won't be able to deploy commercially. That's the idea about what a personal user is. Your interest is learning, researching, tinkering, and all that.
Great.
If you're a commercial user, you still get access to the SDK for free. Our SDKs are open source under Apache 2.0. You get access to console 30 days for free, and then after that, you need to engage with us, which are the enterprise accounts that we're giving away for free. So those accounts, the value of them starts from about 10K per year, and the actual cost depends on how much you use it, like how many models you train. And then when you're done with building, then you need to actually acquire the rights to deploy it into a product. And that process is fairly complex, depends on the use case and depends on the vertical. So I don't want to get into that, but to the enterprise console, I guess like everything should be clear.
Yeah. And then I guess, of course, if there are some questions or some bigger companies would like to talk to you about sort of bigger kind of deployments, they can contact you directly via your website. So exactly. Just talk to Ali. He's very approachable. Although he's being inundated by interests, which is great. So let's see. Okay, so Julius has a question. If his use case is very sensitive to false alarms, is it possible to reach a very, very low operating point using the sensitivity controls you showed in the application, like below 1 FA per hour?
So 1 FA is actually really high in our book. So what we aim for is like, the industry standard that is set by Amazon, which is like 3 per 24 hours, or 1 per 8 hours. So the models that you get from us in like a nominal scenario, they should not give you more than that. So that's the default like sensitivity. You can actually lower it even further to go like something to go to the place that it doesn't even false alarm at all, or you can actually increase it. Now, the other thing that I want to mention, if you can go to our docs on the website, please, and then there's a wakeboard tip. So if you go to Porcupine wakeboard tips. So here's something that is actually kind of important. There's a whole science about how to pick a wake phrase. So you're gonna kind of need to be careful with that, because yes, sometimes the marketing, the product teams are like, hey, this is the name of the product, go with it. But if you look at like the big brands out there, their wake words are not chosen by accident. They always have more than 3 syllables, think Alexa, and they have a lot of vowels. So you want to actually have both. So if you're actually in a place that you can choose a wake word, these are the good things to think about. It's like, hey, do I have 3 syllables? Do I have vowels? So if you actually choose the wake word, it's gonna perform better. It's
like naming a dog. That's what they say. If you want your dog to respond to you, it has to have 2 or 3 syllables that are very easy to hear, and they'll respond. Yeah.
Perfect.
So,
I mean,
it works.
Dog. I mean,
that's right. Yeah, they do respond. All right, so let's see. I think we're wrapping up here. If there aren't any, we might have time for maybe one or two more questions if we can squeeze them in. For those of you who may have missed it, ARM 413 is a secret word. Get an email to hello@picovoice.ai for a chance to win an enterprise license of Shepherd, which is super cool. Let's see, one last one. Do you think wake words will eventually be as valuable as domain names? Oh, and controlled through registration orgs. Interesting. Like the new, would you say the new Bitcoin, right? Wake words.
Yeah, 100%. Yeah, it's like, ETF, right?
Yeah, I don't know how they would register that though, or control it, but maybe it could be. Could be.
I mean, if you think that's going to happen, just register Alexa right now and then ask Amazon to pay you.
Yeah,
I would
exactly.
do that.
There you go. There you go. Yeah. All right. So this has been great. I can't believe it's almost an hour. We kind of like everything went really quickly. So this was super fun. Thank you so much for coming and presenting Shepherd to everybody. And thank you everybody for showing up and hanging out with us today. This will be available on demand on our developer YouTube channel. So look for that in the next couple of days. We'll provide the deck for download, although, it was very, we didn't kill you with slideware this time. So, but feel free to grab that. Picovoice's website should have all the answers to your questions. Also, if you end up making something super cool with Shepherd, make sure that you let Picovoice know, because we could bring you in and on, and we could do showcase what people have actually built with Shepherd. So that would be fun. If you guys want to do that, I am game. We will we'll do a tech talk and showcase that what people have actually created with your product. And I think that's it. So thanks again. Everybody have a great rest of your day or evening, wherever you're tuning in from. And we'll see you here in 2 more weeks. We're going to have another tech talk for you. So look forward to that. All right. Thanks, guys.
Thank you, Mary, for having
Thank you, Mary.
us.
All right. Yep.
Thank you.
Cheers. Bye.
Cheers.
Take care. Bye.